Wilkins, and I'm going to discuss my Cap 2 assignment on the fate of lactate and the Cori cycle, which is the main cycle we will be discussing. See if it wants to move. There we go. Okay, so first I've broken this down into 5 key steps. So the first one, as we see here, we're going to see that glucose is going to break into pyruvate, and this is due to glycolysis. That pyruvate is going to break into lactate, and that lactate is going to move through the bloodstream down to the muscle. Now that lactate is being converted from pyruvate because the oxygen demand is out of its supply. So that's where lactate is building. Now lactate is then going to convert back to pyruvate and then back to glucose. And this is happening via gluconeogenesis, okay? So now that we're here and we got our glucose, that glucose is going to come back through the bloodstream, back to our muscle, and then fuel our muscle for more contractions, okay? So that is the cycle of our Cori cycle happening here. Now to move on, I'd like to discuss our intensities, what happens during that, and the training adaptations we can see through this. So first I'd like to touch point on OBLA, okay, which is that onset of blood lactate concentration. This is basically what is happening and why lactate occurs. Okay, so it is because the production of lactate can accumulate in the blood with a higher intensity, and this production of lactate is occurring way faster than our body can clear it. So that buildup or that burning sensation, right, is not due to lactate, but it's actually due to hydrogen and that buildup that can occur, okay? So the fatigue here is that it becomes a major factor as duration can increase. So this can happen during intervals and high intensity bursts that can present those lactate challenges, and that's that exercise intensity aspect of it. Now moving to our training adaptations. So here are the training adaptations if we train specifically for clearing out our blood lactate. So the training adaptations of reaching that lactate threshold is basically that we're going to see an increase in mitochondria. We're going to see an increase in our capillaries. So then we're able to clear out lactate at a much faster rate. So then we're not achieving lactate sooner, that OBLA sooner. And then that increase in MCT1 and MCT4, again, those are just cell membrane protein enzymes that can just flush out lactate much faster. And then, as you can kind of see here in this diagram or graph, sorry, my computer moved, is that we're going to see that in an untrained athlete, they're going to achieve that lactate threshold much sooner and reach OBLA much sooner rather than in a trained athlete. So again, you can kind of see here in this diagram is that the untrained athlete reaches this around their 50% of their VO2 max, whereas in a trained athlete, they're going to reach this right around 75%. And this makes sense based on the factors presented. Now to move on, I'd like to discuss the differences between lactate and lactic acid. Lactate is what accumulates in the blood during exercise, okay, and it is a byproduct of lactic acid. Again, touching base over here, it's because lactic acid is breaking into lactate and that hydrogen, okay. Now, to discuss a bit more on this, lactate is produced when glycolysis runs quickly and pyruvate ends up exceeding the mitochondrial oxidation. Again, it can't clear it out fast enough, okay? So this is cleared via gluconeogenesis, and lactate can function as a few different things. It can function as fuel, it can function as a shuttle, and a signaling molecule, okay? Lactic acid, now back over here, lactic acid can only exist for a short period of time. Again, it splits into lactate and hydrogen. Now, lactic acid or lactate, okay, is not to blame for that burning sensation or that fatigue that you feel at the end of your set when you are, let's say, doing bicep curls. Okay, so lactate is not that buildup. It is actually the buildup in the accumulation of hydrogen molecules from ATP hydrolysis and glycolysis. And this is occurring because hydrogen is disrupting our pH balance, and because of that, it's disrupting the muscle contraction. Again, this is not lactate, okay? Now that I have made that clear, I'm going to discuss overall kind of what our end factor here is. Lactate, here is what lactate is as fuel and what happens during its accumulation, okay? So lactate is oxidized in the heart and slow twitch muscles, okay? It is converted to glucose via the liver and can be used for energy. We kind of touched base on that when I discussed the Cori cycle, okay? It is also signaling training adaptations, okay? This is a little bit what we touched on. It is increasing our mitochondrial growth, increasing our capillaries, so that we are able to clear it faster rather than produce it, okay, faster. It also rises when production outweighs the clearance, again, kind of like what I just said. And hydrogen accumulation is the issue. Again, it lowers the pH, and that interferes with muscle contraction, okay? So here, just to go over and touch base lastly, is the other fatigue factors that can occur at the cellular level, rather than just lactate, okay? We can also see that inorganic phosphate buildup can interfere with the cross-bridge cycling in the muscle fibers. Glycogen depletion, again, that lowers energy supply. There can also be an ion balance that can weaken signals. And then oxidative stress can also damage muscle function. These are all other factors that can happen and occur beyond lactate or its hydrogen accumulation, okay? So there is that. And yeah, that is it. That is pretty much what I have for you. Thank you so much for listening, and I will see you next time.